All right, here are solutions for perfect problem 5 for Math 251. Coming up with inverse trig function derivatives. So 3 of them to do here. First one, find the derivative arc cosine of x. So the trick for this one is to set it up as y equals arc cosine of x, and then find y prime. Because if you could find y prime and y equals arc cosine of x, what you've just found is the derivative of arc cosine of x, and hopefully it's this thing right here. And since we don't know the derivative of arc cosine of x, we can't just take the derivative of both sides of the equation right now. But what we could do is take the cosine of both sides of the equation, because the cosine of arc cosine of x is just x. And so the advantage of this form of this equation is we can now take the derivative of both sides. So if you take the derivative of cosine of y, how should I write this? I guess I'll just start writing it. Derivative of cosine is negative sine. So we get negative sine of y, but then we're not done because you got to use the chain rule. The outside function is cosine of x. The inside function is y because y is a function. So I have to multiply that by the derivative of the inside function, which is y prime. Derivative of x is just 1. So if I take the derivative of both sides of the equation, I get down here. And I want to find y prime, so I solve this thing for y prime. If I divide both sides by negative sine of y, I get to here. But I don't want to define the derivative of y in terms of y. So what I do is I say I know what y is. Y is the arc cosine of x. So instead of the sine of y, I can say it's the sine of the arc cosine of x. This is better than this, because at least this one's in terms of x. The downside with this one is it can be simplified. The sine of the arc cosine of x can be simplified. Maybe I'll switch colors. We can simplify sine of arc cosine of x. The way you do that is you name arc cosine of x. Maybe let t be equal to arc cosine of x. So we're going to do this little substitution. If we call this arc cosine of x thing, this thing on the inside of these parentheses t, then really I can simplify this thing and just say it's then is equal to the sine of t. So this right here is just sine of t, because arc cosine of x is just t. So really all I got to figure out is what is the sine of t. And I have information about t. I know t is arc cosine of x. So if I take the cosine of both sides, I get cosine of t equals x. Cosine of t equals x. I took the cosine of both sides here. Instead of x, it might help to think about it as x over 1. And the reason that's beneficial is then you can draw this little picture. T is an angle. Maybe I'll throw it down here in my right triangle. If I use SOHCAHTOA, the side adjacent to my angle here is x, and the hypotenuse is 1. So if this is t here, this length is x and this length is 1, I can figure out this length, this opposite length. I need this squared plus this squared to equal this squared. So I need x squared plus something squared to equal 1. So 1 minus x squared has to be this thing squared. So this thing has got to be equal to the square root of 1 minus x squared. Check that. This squared is 1 minus x squared. This squared is x squared. If you add those two things together, you just get 1, which is 1 squared. Anyways, I'm simplifying sine of arc cosine of x. I know that that's sine of t, and if I look at this picture right here, I can say what sine of t is. Sine of t, using SOHCAHTOA, sine of t is opposite over hypotenuse. So sine of t is just the square root of 1 minus x squared. So what I get for my simplified version of this answer up here, maybe I can jump down here, is negative 1 divided by sine of arc cosine of x. But I just said sine of arc cosine of x is the square root of 1 minus x squared. So this is square root of 1 minus x squared. In other words, the derivative of arc cosine of x is negative 1 divided by the square root of 1 minus x squared, exactly what we got up there. That's the basic outline for all 3 of these. Just got to do it 2 more times. For the second one, y equals arctangent of x. Therefore, tangent of y is equal to x. Take the derivative of both sides. Derivative of tangent is secant squared. So I get secant squared of y, but I'm not done because I got to use the chain rule. Multiply that by y prime. Derivative of the right side is just 1. Therefore, y prime is equal to 1 over secant squared of y. I can rewrite that as secant squared of y is arctangent of x. So really what I have to simplify now is secant squared of arctangent of x. So let's see, let's just do secant of arctangent of x. Let's kind of simplify down here. Secant of arctangent of x, I could call that secant of t if I let t be equal to arctangent of x. And that trick's helpful because it's easier to figure out the secant of t because I have this information about t. I know that the tangent of t is equal to x. Maybe x divided by 1. Take the tangent of both sides of the equation you get here. You can draw a picture. Throw t wherever you want. Tangent is opposite over adjacent. So opposite over adjacent has to be x and 1. X over 1. This squared plus this squared has to equal this squared. In other words, this has to be equal to the square root of this squared. 1 squared is just 1. Plus this squared, x squared. So I want to know what the secant of t is. Secant is 1 over cosine of t. Cosine of t, looking at this picture, is adjacent over hypotenuse. So cosine of t is 1 divided by the square root of 1 plus x squared. So what I figured out is secant of t is 1 over this thing. If you think about this as 1 over 1 and multiply by the reciprocal, you get that secant of t is just equal to the square root of 1 plus x squared. And why does that help? Because my answer up here was 1 divided by secant squared of arctangent of x. Another way you can write that is it's secant of arctangent of x squared. Secant of arctangent of x, I just simplified secant of arctangent of x. I said that was equal to the square root of 1 plus x squared. So I get 1 divided by the square root of 1 plus x squared, squared, because of this squared right here. It's equal to 1 over 1 plus x squared, which hopefully, same thing we got up here. All right, one more time. Part C here. C says, do that again for arc cosecant. All right, y equals arc cosecant of x. Strategy is going to be the exact same. We're going to try to find y prime. But first, we're going to take the cosecant of both sides of the equation to get here. Then take the derivative of both sides. You might know the derivative of cosecant of x. I don't know the derivative of cosecant of x. However, you can go to the internet and find out the derivative of cosecant of x is negative cosecant times cotangent. So I get negative cosecant, leave the inside function alone, times cotangent, leave the inside function alone. But then you're not done. You've just taken the derivative of this part. You still have to multiply that by the derivative of this part. So it's times y prime. So what you get is that y prime is equal to 1 divided by, maybe I'll throw this negative out in front for this guy, cosecant of y times cotangent of y. All right. I'd rather not define the derivative of y in terms of y, so I'm going to replace these y's with arc cosecant of x. I'm going to say this derivative is negative 1 divided by cosecant of arc cosecant of, I'm going to run out of room. We'll put this on the next line. Say this is equal to negative 1 divided by cosecant of y is the same as cosecant of since y is equal to arc cosecant of x, then I want to multiply that by the cotangent of y, but the cotangent of y is the same as the cotangent of arc cosecant of x. So I get to here. And now I got to simplify both of these guys. The good news is that one of them's really easy. Cosecant of arc cosecant, those two just cancel out, and I'm left with just an x here. So it'll be 1 over x times something with this negative out in front. I just got to simplify cotangent of arc cosecant of x. Where am I going to do that? I'm not sure. Maybe I can squeeze it in here. Let's try to simplify cotangent of arc cosecant of x. The way we're going to do that is we're going to call arc cosecant of x t. So we'll be able to say this thing is just cotangent of t. We're going to let arc cosecant of x be equal to t. And so we want to figure out what cotangent of t is. I know that if I take the cosecant of both sides of this equation, the cosecant of t is equal to x over 1. And then I also know that cosecant is 1 over sine. So if I draw this picture over here, and I throw t over here, if this were sine of t, I'd say its opposite over hypotenuse is x over 1. But it's not, it's cosecant, so it's 1 over that. So hypotenuse over opposite is x over 1. This is an x, this is a 1. This is an x, and this is a 1. Then you can solve for this third side. I think what you'll get is x squared minus 1. Is that right? If I square this thing, I get x squared minus 1. And if I add that to 1, I'll just get x squared, which is this squared. So that looks right. So from this information, I'm able to draw this picture. And from this picture, I'm able to evaluate what cotangent of x is. Let's see, cotangent is 1 over tangent. Tangent is sine over cosine. So cotangent, no, actually there's an easier way to do that. SOHCAHTOA, tangent is opposite over adjacent. Cotangent is 1 over tangent. So cotangent, instead of being opposite over adjacent, is adjacent over opposite. Adjacent right here is the square root of x squared minus 1. Adjacent over opposite, so I guess I can leave that out. It's this divided by 1, so it's just this. In other words, I've simplified the cotangent of the arc cosecant of x into just the square root of x squared minus 1. So if I go back over here, I needed the cotangent of the arc cosecant of x. That's what I just simplified into the square root of x squared minus 1. So over here I get the square root of x squared minus 1, and I get exactly what I was hoping to get. A quick note on this, sometimes you'll see absolute value signs around this x right here, absolute value signs around this guy. The reason that is true is because actually cosecant and arc cosecant don't just cancel out. You have to put absolute value signs in there to take care of restricting domains. You can just leave them out as long as you just ask if you only use this when x's are positive numbers. So I'm just gonna let that slide and we'll just call it x here. But just a tiny note in case you're nitpicking, this could be square root of, or absolute value of x here. Okay, good enough. That's the end of this thing.